Okay, I think I must have been a little bit tired yesterday when we were working on this, because we were so close. We were talking about the fact that the derivative of the arctan is the n squared plus 1. And so instead of doing by parts, which now seems kind of silly, we should have been talking about substitution here, right? Because if we let u be, sorry, that's not writing, tan, oh, tan inverse, so I don't know why my pen is not writing today, tan inverse of n, then du has to be the 1 over n squared plus 1 dx, or dn, right? And so we actually have both of those in here, and so if we use the integral test, we can take the 8 out, and we can substitute in u dn and integrate that. So when we're doing the integral test, remember that we're saying that the sum of the series from n equals 0 to infinity is f at 1 plus the integral from 1 to infinity of the series, right? And so we could write it like that. So f of 1 for this function, if we get 1 for a tan, then that's pi over 4, right? So I would have 8 times pi over 4 over 2. And so 8 times pi over 4 over 2, because if I'm putting 1 in for n, that would be 1 squared plus 1 is 2. And so that's actually going to give me pi over 2 divided by 2, pi over 4, I think. Is that right? 2? No, just pi. 2 goes into 8 4 times, and then 4 times pi over 4 will give me just pi, right? Okay. So that's the first term in the sum for the integral test. The second one, when you when you integrate this function, I think what you should get is 4 tan inverse squared. Now, as tan inverse goes to infinity, the limit is pi over 2. And so when you substitute in the infinity part of that, it's going to be 4 times pi over 2 squared minus, and then you've got 4 times pi over 4 squared when we substitute the 1 in for n there, right, when n equals 1. And so we've got pi for the f of 1 part of this, and then whatever this turns out to be, it looks like we'll get pi here, and here we're going to get pi over 4. So we have pi minus pi over 4. And so, are we getting a negative sum? I don't think it matters, though. As long as it's not infinity, it's going to converge. And so I think our conclusion for this one is that it's going to converge. So these are kind of fun for me when I'm awake. Last night I had been working again on a couple hours sleep, so we got close, though. If you want to send me a couple of the other ones that we looked at last night and give me a little bit of time to work on them, then I'm happy to send you back what I come up with, and maybe between that and what you get from your tutor or your TA today, we can work our way through the assignment, okay?